Hi, okay, now we have a velocity time graph, okay? We are going to analyze each interval, each point of this graph. So let's start. The first point is that the object starts moving to the east, okay? The problem says that the beginning, the time equals 0, the initial velocity is 5 meters per second, okay? So the initial velocity is going to be 5 meters per second. Okay, so to the next 2 seconds, the object moves, right? Okay, and this first interval, okay, this first interval, we can calculate, yeah, the acceleration of the object, okay? And remember that acceleration's formula is velocity final minus initial time final minus initial. So the final velocity on the first interval is going to be 0, and the initial velocity will be 5. The final time 1, the initial time 0, sorry. So that's going to be minus 5 meters per second, or meters by square second. Okay. So very good. Okay, now the interpretation. Yeah, the interpretation on the first interval is that object is slowing down. Okay, is slowing down. And yeah, of course, at 1 second here, this point over here, at 1 second, okay, the object doesn't move, okay? It stops. So the velocity at this point is going to be 0. Okay? So the object doesn't move. Okay. Very good. Doesn't move. Okay. Now, after this point, we have the second interval. Okay. In the second interval, yeah, of course, we can calculate the acceleration. Final minus initial, final minus initial, minus 5 minus 0, dividing by 2 minus 1. And the acceleration will be minus 5 meters per square second. Okay? Yeah. But here, the interpretation is different. Okay? Yeah, and 1 second, the object doesn't move. Then from the next 1 second, the object accelerates on the opposite direction. Oh yeah, so accelerates to the west. Okay, that is interpretation. Accelerates to the west. Okay, and then on the third interval, okay? And the third interval, okay, the acceleration is gonna be -5 minus -5 dividing by 6 minus 2, okay? Because the final velocity here is -5 and the initial velocity is -5. Okay, and the final time is going to be 6 and the initial time is going to be 2. Okay, so, oh yeah, the acceleration is 0. Okay, when acceleration is 0, we have two different options to interpret what is happening here. Okay, number one, the object doesn't move, and number two, the object is moving, but in this case, at a constant velocity. And that is what is happening right now. Okay, the object is moving with a constant velocity. Okay, the constant velocity is going to be 5 meters per second. So, yeah, constant velocity. Constant velocity. Oh, very good. Okay, it's moving at constant velocity on the west direction. Yeah. Okay, this is important. All the trajectory that the object is making right now in this interval that is under the x-axis, the direction is west. Okay. Okay, so appears the fourth interval. Okay. What happened here? Okay, in the fourth interval. Okay, the acceleration is going to be 0, the final velocity, -5, the initial velocity, 8, the final time, 6, the initial time. So here the acceleration is going to be 5 dividing by 2 meters per square second. Oh, okay. Now, the interpretation, okay? On the fourth interval, the object is slowing down. Okay. Yeah, why? Because here on 8 seconds, this point over here, and the time is 8 seconds, the velocity of the object is 0 again. So the object doesn't move. Okay. Very good. Then, yeah, it's going to be the, let me see, wait, the fifth interval. Okay. Okay, so at this interval, yeah, again, the acceleration is going to be final 5, initial 0, final 10, initial 8. So the acceleration is going to be 5 divided by 2. Okay, very good. Here, the interpretation is that the object accelerates, but in this case, accelerates to the east. Okay. Okay. So the final interval, okay, number 6. Okay. In this case, okay, the final velocity is going to be 0. The initial velocity is going to be 5. The final time 14 and the initial time 10. Okay. So the acceleration is going to be 0 minus 5 dividing by 14 minus 10. That's going to be minus 5 dividing by 4 meters per square seconds. Okay, excellent. Yeah, and the interpretation is that the object is slowing down. Okay, very good. Okay, I calculate all decelerations for the entire graph for each interval and made the interpretation of slowing down, accelerates, constant velocity. Yeah, the object doesn't move at that point. Yeah, I did all the analyzing or the analyze of this graph. So very good. Now, okay, maybe the next question is, for example, we can calculate all the distance. Okay? That is an important calculation. Okay, so let me see. Okay. I will take only the graph and analyze it, and then I want to do the calculations. Okay, so on this first interval, okay, the first interval, the fifth interval, and the sixth interval are above the x-axis, and the second, third, and fourth intervals are under the x-axis. Okay, that is very important. Why? For example, if I can, or if I want to calculate the distance on the first interval, okay, remember that on a graph, velocity versus time, and this is important, okay, velocity versus time. Let me see. All this entire area, is going to be the distance that the object traveled. Okay, remember, okay, the area is going to be the distance. The area between the straight line and the x-axis always is going to be the distance. So for our first interval, look at this. Our first interval is a triangle. Okay, so the area for a triangle is base by height divided by 2. Okay, So remember, in the area of a triangle is going to be base by height divided by 2. So for the first one, okay, it's going to be base 1. Okay. Yeah, 1. Look at this. 1. The height is going to be 5. So 1 by 5 divided by 2 is going to be 5 divided by 2. That is going to be 2.5 meters. That's it. Okay, this is a distance. Okay. The distance on the second interval. Okay, come on. Let's look again the graph. Okay, is another triangle. And I refer to this triangle, base, height, and it is this triangle here. Okay, so the base is going to be 1 because the distance between 1 and 2 is 1. 1 by the height is going to be 5. No minus 5. No. 5. Okay, remember the sign, it will not work here. Okay, so base by height divided by 2 is going to be 5 divided by 2, and it's going to be 2.5 meters again. Okay, now on the third interval, okay, the distance on the third interval, it's going to be that, yeah, that's a rectangle. Okay, and a rectangle, the area is large by the width. Okay. Okay, so large, the distance between 2 and 6 is 4. And the width is going to be 5, right? So 4 by 5 is going to be 20 meters. That's going to be the distance on the third interval that the object made. Okay, excellent. Now, the fourth interval. Okay, here we have another triangle. Okay, the base is going to be the distance between 6 and 8. This is going to be 2. The height is going to be 5, and dividing by 2, yeah, because that is the formula. 2 by 5 divided by 2 is going to be 5 meters. Okay. Now, interval numbers 5. Okay, the distance is another triangle. Okay, and it's going to be, the base is going to be 2. Height is going to be 5. And divided by 2 is going to be 5 meters. Again, on the fifth interval. Okay. And the last interval, that is number 6. Okay, there is another triangle. Okay, the base is going to be 4. The height is going to be 5, and divided by 2 is going to be 10 meters. Okay, so 10 meters. So if I want to calculate the total distance, okay, the total distance is going to be 5 plus 20 plus 5 plus 5 plus 10. Okay, so 30, 40, 45 meters. That's going to be the total distance. Okay, 45 meters. Okay, very good. Excellent. And now, what about the displacement? Okay. Oh, yeah. What about the displacement? If I want to calculate the displacement for each interval, again, I will need the distance first. Okay. Okay. So I am writing again all the distances to calculate the displacement. Okay, remember, distance is without an arrow above the letter. This is displacement. Yeah, and the displacement, of course, that is going to be in a direction at the end. So let me see, I will write it. Okay, so come on. Okay, on the first interval, okay, the displacement. Remember, the object starts moving to the east. Okay, that says the problem, the initial statement on the problem initiates to the east. Okay, so the first displacement on the first interval is going to the east. Okay, east. But in the second interval, after the object stops, the object now is moving to the west. Okay, and remember, all the intervals under the x-axis is going to be on the opposite direction from the beginning. So the second interval is going to the west. The third interval here, yeah, also is under the x-axis. So the direction here is going to be west too. Okay. Okay. Then on the fourth interval, the direction too is going to be on the west. On interval number 5, okay, now it's above the x-axis, so the direction is east. And the final interval here also is going to be east. Okay, so there it is, the displacement for each interval. If I want to calculate the total displacement, okay, what I have to do, the total displacement. I'm going to erase this. Okay. Okay, the total displacement. Okay, of course, you have to do an addition for each interval, for each direction here. So the easier way to do this, for example, from the distance, because distance, you have to do only all the addition of the distance. Yeah, so the total distance is 45. And the total displacement, okay, you can do this. The total displacement is gonna be, okay, you do an addition of all the intervals that is going to the east. So 2.5, 5, and 10. Okay, you do an addition. So that's gonna be 17.5 meters to east. And now you do the addition, all the displacement that is going to the west, or going to the west. So 2.5, 20, 5, and that's it. So it's going to be 27.5 meters to west. Now we have to do an addition, or yeah, an addition for these two different displacement. But here, remember that if we have two vectors with opposite direction, that will be a subtraction, okay? And yeah, let me see. Here, the easy way is to do a subtraction between the greatest number, okay, that is 27.5 minus the 17.5. So yeah, 27.5 minus 17.5, that's gonna be 10 meters, okay? 10 meters. But yeah, the direction will be from the biggest number. So they're gonna be west, okay? Because 27 is greater than 17.5. And if you want to look the graph, an addition of these two vectors here, okay, I can do that. Okay, we have 17.5 meters to the east and 27.5 meters to the west. Oh yeah, and the final displacement is going to be the arrow between the origin and the final arrow here. Okay, so this is going to be the displacement. Yeah, and that's the reason why we did that subtraction, right? Oh yeah, this is the displacement. Okay, this is a displacement, the total displacement of the object. And so that's it. We finished the exercise. Very good.